All right, well, good afternoon, everyone. My name is Bill Dickinson. I'm the Director of Technology at ESS. And today is the inaugural webinar for our fall Virtual Tech Exchange series. Today's webinar is going to be on open source blockchain. We're going to go over a couple things and we'll just dive on in. A word about the rest of the series. We will be having another webinar every 2 weeks for the next almost 3 months. And we'll go through the end of December. We have at least 2 more on blockchain throughout that time, and then we're going to have some on GIS, some on the ESS internship program, and then maybe another 1 or 2 other things in there as we figure out what's going on. So I'll continue notifying everybody, and hopefully everybody will be able to show up. All right, so let's dive into open source blockchain. What we're going to look at today, and I'm going to turn my video off. We're going to look at 4 things today. We're going to look at what is an open source solution. We're going to talk. So in that, we're going to talk about what it is that we do to put together an open source tool as well as open source solution, and the pros and cons of an open source solution versus a commercial product. Then we will talk about some open source blockchain platforms. And then we'll talk about back-end development and front-end development for open source blockchain solutions. And the thing you'll notice there is that my screen is not advancing. There we go. With the back-end and front-end, you'll hear out there people talk about this DApp development or distributed application development. And that's part of the blockchain solutions, both the front end and the back end. I went through this thing the last couple of weeks trying to figure out how to explain DApp development, and it just kept getting more and more confusing. So what I've decided is to go into the 2 things that are a little bit more clear, which is the back end development and the front end development. So we won't use the term DApp here, but you may hear it when you're out in the wild talking about blockchain solutions. All right, open source solutions. Here's the definition. All right, it was originally decided to do it open source in response to the limitations of proprietary code, or what we call commercial code, right? As opposed to the commercial or proprietary code, which is completely controlled by a single source or entity. In open source solutions, an entire community works together to provide high quality, peer-reviewed code. So in the end, that's to provide a better product. Certainly proprietary or commercial products can be good products, but they also tend to be ones that are very focused on what the commercial entity that controls it decides is what needs to happen. Whereas with an open source that's directed by the community, everybody follows kind of a communal vision and work towards something that is better for as many people as possible, or for the greater community itself. It is all built from publicly accessible tools and technologies. That means that anyone can see, modify, and distribute the underlying code. That's one of the key principles of open source, is that the code itself is available to anybody who wants to look at it. So I can go to any open source piece of software, I can dig down through their project and find their source code and see exactly what it is that is coded into the software itself. Open source solutions also use a decentralized development approach, which is very similar to what we talk about with blockchain and open blockchain solutions. Right, I talked about a community of people. They all work towards a common vision. And so everybody out there is working together, on their own little pieces to create a greater whole. And finally, an open source solution promotes universal access through the open or free licensing agreements. Right? And the big thing here, of course, is that it reduces and removes the cost barrier. Commercial products, especially when you're talking about certain specialized pieces of software, can run you into the thousands of dollars for licensing. whereas equivalent open source software will either be free or very low cost. So it makes it easier to get into the software and actually do things with it. Now, there is a thing called the Open Source Initiative. That's the group and the entity out there that is really the center point for all open source development. And there you got their tagline: to promote and protect open source software and communities. And they've put together a list of 10 items that is the open source definition, or the OSD. And a lot of that doesn't really make that much of a difference. The big thing are number one, the free redistribution, like we just talked about. You know, if you're doing an official open source solution or piece of software, it must be freely available. You know, you could go down the line and then develop something derived from the base free open source solution that you could commercialize or make some money off of. But the base code and the base software has to be free and open. The other ones are number 7, 8, 9, and 10, which is all about licensing, right? And those are kind of particular. We don't need to go into those in any real detail. But it basically says that the licensing is also open. There's several of them that you can get to license your software or your solution, but the end result is always, it's an open license. You know, there's no restrictions on the use of the software, and it has to be technology neutral. So we got some advantages by using an open source solution, and you can see them here. It's, you know, quality, flexibility, reliability, innovation, control, licensing. In general, when you have complete visibility into the code and a large community of people all working towards a common vision, this tends to promote a greater effort and ability to get the code right before it goes out into wider use. And access to the source code also makes it possible to extend the solution to specific needs. So I might have a piece of software, like what I use a lot is GIS or geospatial software. And there's an open source solution there called QGIS. I can get to the code and I can extend it in specifically the way I need to extend it, which is not something that I can do with commercial products. Some of them give you a little bit of, some of the commercial products give you a little bit of ability to extend their software, but it's not very common and it's usually pretty difficult to do. Now, the reliability goes with the quality, right? We have a peer-reviewed development process. So when people are out in the community are developing the open source software code, before it goes into the main branch and becomes part of the freely available public software, it is reviewed by a number of people in the community that already know what they're doing with the code and what they're doing with the vision of the solution. So that also helps promote the quality of the end software. Now, open source technologies also tend to be closer to the cutting edge than commercial tools. I mean, that kind of makes sense. Commercial tools want to play it safe. They want to be able to provide a product that is very stable and very useful to the widest possible number of users. That tends to keep them away from bleeding edge solutions and technologies, and to rely on things that are tried and true. So open source tends to gravitate for those people that want something on the cutting edge. So the innovation tends to be a lot higher in open source technology than it is in commercial technologies. Now, the point on control is the control you have over updates to the software dependent on whoever's development cycles. Open source is continually being developed. The community is out there every day, every week, working on new pieces and releasing new components to the major branch. Whereas proprietary software, the commercial software, you're completely reliant on their software development cycle. So an example is, again, with the GIS software, the main commercial software I use, we might ask them for a bug fix or a new feature, and they'll tell us, oh, great, of course we'll do it, but it's going to be in the next development release, 2 years from now, because they already have a list of things that they are working on. So they can't just throw new things in, whenever they want to. With open source development, you put an idea out there. If somebody else really likes it or really finds it useful, they'll jump right on it, and you'll probably see it within the main software pretty quickly. Or you can develop that new tool or capability yourself. And of course, the licensing, the OSS licensing is either free or very low cost, which can make a huge difference. The main commercial GIS software I use, the licensing can be $1,500 per user. The equivalent open source GIS software is free to use. I can just go download it from the website and start using all of the capabilities within it right away. There are disadvantages to open source, right? Compatibility is one of them, right? OS software, and OS is just an abbreviation for open source, takes a little bit more effort to get it running on your workstations, especially if you're using either slightly outdated hardware or your OS is not the norm, right? Most people in the world use Windows, but if you're using Linux, sometimes it's a little bit harder to get things running. And OS software, being on the cutting edge, tends to kind of compound that a little bit, not hugely. I mean, there's some that definitely make it very easy to install and get running. Others make it not so easy, and you have to spend a lot more of your own time. There's also, it tends to be support issues. Most OS solutions do not provide dedicated support teams. It's one of those things where you have to go to the community boards and ask for help and try to find somebody that knows the piece that you're having a problem with, and then they will help you through whatever it is. It's usually not that difficult to find somebody that will help you, but you do have to go to that slightly additional effort to do that. There is additional expertise required in managing and maintaining and supporting open source software. And that goes back to the comment about, if you're running on Linux, it might take a lot more specialized Linux administrative knowledge to get the software running and to maintain it and to update it and keep it going. And then usability can be an issue. The commercial software products, I think of Microsoft Word or PowerPoint or Google Earth or Google Maps. And these are all things that somebody has spent a lot of time and effort and money on to make it usable for the widest possible audience. Open source software, they don't tend to go that far down the usability route until they get a very large community of users. When it becomes very popular, then it becomes more important to the open source project to spend more time on usability. And some of the open source solutions are very good at the usability. Some, of course, are not. And it's very important to keep in mind that open source does not mean no cost. A lot of times people think that. They think, oh, open source licensing, it doesn't cost me anything, it's free. I'm going to go get it and I'm going to start using it. Especially if you're trying to do that in a enterprise environment and get it out to a lot of people that are going to rely on it on a day-to-day basis. What happens is the licensing fees go down, but the other costs usually go up. The cost of integrating the solution, the open source solution, into your enterprise environment, the cost of potentially developing against it, and the expertise cost needed to keep it going. these tend to be people costs, right? You need to have specialized people and maybe more people that can do all these things to keep the software running, to keep it installed, get it out there, provide user support, which you don't tend to need as much of when you're using a commercial product. I mean, you think of it like Microsoft Word. You know, Word is relatively straightforward. Everybody kind of knows what it does and how to use it. But if you use the open source version, which is called OpenOffice, yeah, you run into some more problems, you know, because the tools aren't in the same place. They're not coded the same way. They don't work quite the same way. So it's a little bit different, and the costs end up coming on the back end of support and maintenance. So now let's talk about some open source blockchain platforms. And we got to start with the big one, Hyperledger Fabric. Right? I mean, that's the one, it's the underlying blockchain technology for both the IBM blockchain platform and the Oracle blockchain platform, which we talked about in the summer virtual tech series. And they use it for a reason. I mean, Hyperledger is a large, what they call greenhouse of tools and capabilities, all based around blockchain and distributed ledger technologies. It's been around for quite some time. IBM is, I believe, one of the founding members. It's one of the larger contributors of the system, as is, I believe, Oracle, because this is what underpins their own technology. And it has a lot of good things about it. I mean, there are other things, like we used Hyperledger Burrow for a little bit in our lab, just testing it out to see how it would work in relation to Hyperledger Fabric. But then there's other pieces of the Hyperledger family here that you can see. So you get like mobile application support. You've got framework benchmarking. You can model and build blockchain networks with Composer. So there's a lot of tools within the Hyperledger tool set. That is the wrong way. But the real things, big things to take away here is, first of all, that it's a private permissioned blockchain network. Right? That means that only those people you have designated and allowed to get into the blockchain solution and the blockchain network, only those people are going to be able to get in and do things. The consensus mechanism is voting based. Each node can vote on the potential of a new block being added to the blockchain. And that's how it's determined what is valid and what is not valid. Data privacy is provided through the blockchain channels in Hyperledger Fabric. You can create individual groups, within your blockchain network, and only people that have been allowed into that group can see the data stored in that particular group or channel. And not all blockchain platforms provide the ability to do that. It does use smart contracts, as they all do. It has a REST interface to the blockchain network nodes, and that's very important. REST is the web technology that allows something like a web page to connect to the data and the interfaces and the capabilities of the backend, right? So for each node to have a REST interface means that you can develop a DApp, a distributed application based in a web application that can then interact with the blockchain network itself. You need that REST node to be able to do that. Hyperledger Fabric also provides hardware-based protection of digital keys. Again, something that not all blockchain platforms provide. It also has a very extensive community support. It's been out there for a long time. It's probably the oldest blockchain open source project, and there's been a lot of work done on it. So the community support is very wide and deep. The other blockchain platform, the open source blockchain platform that you'll hear about out there is called Enterprise Ethereum. Ethereum is really, I mean, it's something different than what we would want to really use in a enterprise environment, because it's a public blockchain network. And we don't typically want to use public. I mean, that means that it's open to anyone that is on the network. All of the data is available to everyone. You know, and certainly in the environments that we tend to work in here at ESS, that doesn't typically fly. We need to have a private and a permissioned blockchain network to get the work done that needs to be done. The consensus mechanism is proof of work, which is just like Bitcoin. And Ethereum is more of a financial type of blockchain solution than, say, Hyperledger Fabric. Right? So it is going to be more Bitcoin-like in the way it does things. It is looking at what's called proof of stake, which is an odd way of doing consensus. But that consensus is, as you want to add a new block to the blockchain, the consensus is reached by whoever pays the most in Ethereum coins to get that block confirmed. I'm not sure why you would want to do that. So it sounds kind of odd. I mean, it seems like it would open it up that whoever has the most money gets to determine what happens in the blockchain. So that's kind of weird. It also uses smart contracts and has REST node interfaces, but it's public, so there is no data privacy built into it. It does have a pretty extensive community support. It is one of the older public blockchain solutions out there. Now, Quorum is based on Ethereum. It's what they call their private permissioned version of Ethereum. So it still tends to use the same Ethereum setup. You know, when Ethereum runs, it runs off of this electronic digital money called nope, just went out my brain. Oh well, it has its own built-in digital value, digital coin. So Quorum does the same thing, but it doesn't really use it as well or in the same way. So it's Ethereum's private permission blockchain network. It does use proof of authority for consensus, which means that you have to have a number of nodes agree that the people that are, whoever's adding the block has been given the authority to add blocks and data to the blockchain. It does have smart contracts. It does use REST node interfaces. It does have data privacy, and it does have community support. You know, it's not a widely used platform, so the support for it and the use of it is not quite as large as the other ones. Corda is another open source project. It's an interesting one. It uses private permissioned blockchain networks, but it doesn't use a traditional consensus approach. It does what they call per transaction consensus, right? And it focuses on the validity and the uniqueness of the transaction request. Excuse me. And if those two tests pass, then it allows the block to be written to the blockchain. It's actually, it's promoted as being faster because of this, because it's not really going out and polling everybody on the blockchain network to reach a consensus. It has these two tests that say if these two tests pass, then we're going to say that it has reached consensus and move on. Right. So it's much faster blockchain network than the other ones. For channels, it uses need-to-know bases, which is really just, if you think about groups of people on any computer network. If you create a group on a shared network folder on your computer, on your local network, that's a need-to-know basis type of approach. So Corda's channels are doing the same thing. You create a group of users within your blockchain network, and you say that these are the ones that have the need to know into this particular set of data or set of functionality. It also does its data privacy through the need-to-know basis, so it does the same thing. And then it does have REST node interfaces. It does have smart contracts. And it does have a certain amount of community support. Again, neither Corda or Quorum has the extensive community support that goes on with Hyperledger Fabric, but there is support for it. It is out there, and it is doing things and being used. And the last one is openchain. Openchain you can do either public or private, so you can go back and forth, or you can set it up to do one or the other. It does what's called partitioned consensus, which effectively, whoever administers the specific assets that are being dealt with at any given time are the ones that assign the validation. And they can set up rules, right? So that as a new block or transaction is trying to be written, if specific rules are met, then the asset administrator has effectively given permission for that block to be added to the blockchain. And they do client server versus peer-to-peer, which is another approach at trying to improve the performance of a blockchain network. So if you think of the standard blockchain network that you would see in Hyperledger Fabric, that's a peer-to-peer configuration. They're all talking to each other, and they all have effectively equal rights on the blockchain network. Client-server approach is more like our traditional setup, where there is a centralized server that keeps track of validation and consensus, and then all of the clients talk to it. But then the individual nodes don't talk to each other. They all talk to the main server. So that boosts the performance of the network as well. But it's not doing your standard and what we consider to be really distributed blockchain network or solution. They do use REST node interfaces, and they do have smart contracts. And there is a certain amount of community support. It's probably the one with the least amount of community support. So let's talk about the back-end development a little bit. There's a couple pieces to back-end development for a blockchain solution. The first one, of course, is the chain code itself. And chain code is what we talk about. It's the smart contract code. You'll hear it either as a smart contract, or you might hear somebody call it a chain code. And the real point here is, for programmers, this is no different than programming anything else. If you're a web programmer, or if you're a Java programmer or software programmer using some other language, the way you program is effectively the same. So learning how to develop chain code and develop smart contracts really is as easy or difficult, depending on who you are, as picking up a new programming language. It's just a matter of the differences in syntax from one language to the next, or one coding methodology to the next. And that's why we want to talk about languages. Smart contracts are written in multiple different languages. And the language used depends on the blockchain platform. Right, so if you look at the middle column there, the language support, we can look and see that Corda uses Java and Kotlin. Ethereum, the smart contracts are programmed in Solidity. Hyperledger Fabric uses Go, Java, and Kotlin. And those are the only three that we have from the ones we've talked about. You can also see there's other blockchain platforms out there too. But the point here is that a number of these smart contracts, the blockchain platforms, are written in Java or Go. Kotlin's pretty popular. Python. Python and Java and even JavaScript are all pretty common out there, and a lot of people already know it. So being able to turn around and start writing smart contracts in one of those particular blockchain platforms shouldn't be that difficult. Now, when you do the back-end development, when you're developing your smart contract or your chain code, you typically use what's called an IDE, an independent development environment, right? And that's just a piece of software that makes programming easier. It tries to bring all the pieces together and make it easier to do some actual programming. And these are some pretty popular and common IDEs for blockchain. We've got Microsoft Visual Studio Code, Tana Studio, Selenium IDE, IDE.corda.net, Truffle Suite. There's a whole ton more. It's interesting to note that Selenium, which is the part of the Ethereum platform and is used to program Solidity. Solidity is the programming language for the smart contract. Is pretty much specific and by itself, right? If we go back and look here, nobody but Ethereum uses Solidity for their chain code, right? So kind of another reason not to pick Ethereum. We generally don't want to be doing public blockchains anyway, which is what Ethereum is. And we also don't want to be pigeonholed into using a language that is not easily portable somewhere else, right? And we've tried most of these in our lab. We certainly use Visual Studio Code a lot. I've used Tana Studio a lot over the years. Truffle Suite is a nice setup. It really kind of helps you do your own development without having to be connected to a blockchain network. We haven't really done much with Selenium IDE or the IDE.corda.net, but we'll probably play with those at some point. Visual Studio Code is probably my IDE of choice, right? Because it can do every single language that is out there that you need for smart contract development, even Solidity. So it makes it a really nice one-stop shop for your programming needs for smart contracts. There are individual plugins for Kotlin, for Go, for all the different ones that are used. And what's nice is there is a specific plugin for the IBM blockchain development, and it's that particular plugin connects very nicely and quickly to an IBM blockchain network and allows you to do some local development with various blockchain pieces without having to be like totally connected to the blockchain network itself. So I mean, when we talk about backend versus front end, right? Backend is everything that is running on the server. And that's the smart contract and the blockchain network itself. Then we have our front end development, which I'm borrowing heavily here from web application terminology. The front end is typically your GUI, your user interface to your application. It's the web page, right? You go to a web application or a web page, and that's the front end, right? It has all those little tools on it that you need to interact with the capabilities in the back end. Well, front end can mean one of two things. It can be a web application or it can be a desktop application. Right? At one point, front end would only mean web, but I think the lines are blurred to a great degree. So I like using it for both the idea of a web front end or a desktop front end. You know, the web front end, of course, will be the thing that you get on you go on the web and you get a web page. Desktop can be any type of desktop application, and it can be programmed in Java or Python or whatever you want to use. The pros of using the web approach, of course, is the cross-platform, right? Web applications run pretty much anywhere. All platforms have a web browser. There are little nuanced differences between browsers and OSs and how the browsers run on a OS. But for the most part, it's pretty good job of cross-platform. Web applications also tend to be very lightweight, right? It's not, when we say lightweight, we mean lightweight on the local system. So a web application, it just runs within your web browser. You don't need to download anything or download a piece of software, install that software, and have it running on your local system. You're doing it all through the web browser itself. No additional installation. If you have a web application, you also have automatic updates. As I develop the web application, I include my updates and my changes. I deploy it out to the web server. You don't see that. The user just gets all of that information automatically, all those new capabilities automatically the next time they use the application. As opposed to the pros of the desktop, right? The pros of the desktop is that there's no internet required. With a web application, you pretty much have to be connected to the web to use the application. The desktop has better use of local computer resources. So if you need something that is graphics intensive or processor intensive, you really can't do that in a web application, but you can do it in a desktop. You certainly get better privacy controls and better performance out of desktop as opposed to over the web, depending on the complexity of the application itself. Your cons of the web application, of course, are the security threats. They're always out there. You know, we're always getting every day, every week, new information or new warnings about whatever worm or virus or whatever is out there. Don't click on this on the web. Don't use this on the web. Don't do whatever. The security threats are pretty constant and real when you're on a web application. Of course, dependent on the internet and the performance, depending on what you're doing, it tends to be poor. The cons of a desktop, of course, is not as portable, right? You have to actually have the install file and you have to install it and get it running and upgrade it when necessary, which is all part of the deployment and the installation and upgrades. For blockchain solutions, you have to make the decision early on as to whether you're going to be a web application or a desktop application. 9 times out of 10, maybe you're going to want to choose to be a web application. That gets you to more people in a better way. It meets the distributed part of our solutions development better. And there's a lot of good free things that come with being a web application. When you want to use desktop is under certain conditions. If you need additional security or additional processing or graphics, that's when you want to look at using a desktop client as opposed to a web client. And we have certain languages that we use in both of those development approaches as well, right? With the web, we focus on HTML, JavaScript, CSS, JSPs, and then certain frameworks. You know, there's a whole ton of frameworks. And there's just Ruby on Rails, Ruby on Rails. Those are just 2 of the multiple frameworks that are out there. But it's all standard web application and development languages and approaches. So if you do web application development, that's part of your job or something you worked on before, it's very easy to roll into being able to develop front ends to blockchain solutions using a web application. And then desktop is typically either Java, Python, or Go is a newer one. It's probably only been out there a couple years. Not quite as popular. The two big ones are Java and Python. And then you have some frameworks. Swing is a Java framework, and a framework just kind of helps you develop what it is that you're working on. Gives you some shortcuts. The interesting one there is this one called Electron/Node.js. That's a relatively new desktop framework, a new client framework that really is built using JavaScript and HTML and your web tools. So if you're very used to doing web application development and you need to do a desktop client, going and figuring out Electron might be the way to go. It makes for an interesting crossover from your web development to your desktop development. As with back-end development, in front-end, we also have a number of IDEs. Again, Microsoft Visual Studio Code. And that handles pretty much all the languages you're going to come across. You have Aptana Studio, but it's for HTML, JavaScript, Python. It does have other ones as well. Eclipse is very good for desktop or thick clients that you need to develop on desktops, like for Java and Python. PyCharm, it's out there. It's a Python one. And then code blocks for C and C++ if you want to program in those languages. But you'll notice again that we got Visual Studio Code. Visual Studio Code tends to be a all-around good IDE for programming needs. It's a good one to start with. The only thing I haven't found yet with it is a more visual way of developing web pages. I mean, Aptana Studio has a lightweight web server built into it, so you can see the web pages the way that they should look on a web browser within the IDE itself. I imagine Visual Studio Code has the same thing as a plugin somewhere. I just haven't found it yet. It makes for an easier and better approach to developing your web applications or web interfaces. All right, so that's a quick overview of open source solutions, some open source blockchain platforms, and kind of what goes into the development practices on the back end and front end to get an open source blockchain solution on the books, going into production. Thanks for your time, and hopefully we will see you at the next webinar in 2 weeks. The next one is going to be on QGIS, which is the open source GIS software that we use around here. So thank you very much. Have a good day.